So I know it's negative x to the second minus some.
Let me show you the answers here for these. Here you go. I'm going to go by the calendar for sure. See, I'll put it. It would definitely be better to do it tomorrow.
And then you distribute the negative.
All right, so you had a chance to look at these answers. Do you guys have questions, concerns that any of us can help you with? Or for two, you could say infinitely many solutions. That would work too for number two. Basically, any real number would work there. Anything I can do to help you guys?
What's the solution?
I like this one.
All right. So then, today's going to be a little bit different. As I mentioned last time, we're going to be looking at graphs. So for this first exercise, I want you guys to get with a partner, and I think just about everybody is in a place where they have one table partner. No, Coy, no, stay.
You're bad, Kate.
I want you to find a table partner with you, Coy, not at a different table. Chase is already sitting over there by Anna, and they can work together. I want you guys to think about how you could draw the graph of a quadratic like this. Think about what we've done with lines in the past, and please don't stare at me and expect me to just like give you the magical answer here. I want you to explore and try, and I want you to like totally succeed or totally fail or somewhere in between. I want you to explore, try. Think of some graphing strategies you've used in the past. Give you a few minutes to do this, and I'll hear some answers from you guys, and then we'll try to clean it up if needed. Ready, set, go. This. I'm going to do a little direct teaching here. A graph, listen now. Hey, listen. A graph is simply a visual representation of all the points, are you listening? That make the equation true. So for instance, if I said, I think the point 0, 2 is on the graph here that we're supposed to, there we go. I think the point 0, 2 should be on the graph. You know what that means? The point 0, 2 should make this equation true. Let's find out if it does. So the point 0, 2, that means y is 2 when x is 0. 2 equals 0 minus 0 minus 2. 2 equals, ooh, that's totally false. So what does that mean? And it means that the point 0, 2 is not on the graph. Let's say graph. Because we're going to find this is not a straight line.
0, -2 would work.
Oh, okay. So where on earth did you come up with that?
Well,
Just based on seeing the numbers there?
yeah.
Okay, so you are correct that is going to be true. Here's how you could actually defend it, other than the I saw pattern, which is actually a pretty cool thing. You could actually generate all of your true points, like all of your points that actually are on the graph, by just doing an input-output table. So check this out. What if I tried to plug in, bless you, probably the smartest number ever, right? Plug in a 0. Bless you again. Let's think about what happens if I plug in a 0. I'd get y equals 3 times 0 squared minus 6 times 0 minus 2. Don't we get y equals negative 2? So that right there, as Noel noticed, that would actually be on the graph because it makes the original equation true. So 0 comma negative 2, there it is right there. This graph probably has more than one point though, doesn't it?
Definitely.
How could I find another point?
Try another number. Do 1.
How about 1? Okay. So if I plug in a 1, I would get y equals 3 times 1 squared minus 6 times 1 minus 2. And if I do a little order of operations, I get 3 minus 6 minus 2, which is?
Negative 5.
All right, so 1, negative 5 is right about there. At this point, it looks very much like a line, doesn't it?
Yes.
Let's try negative.
Let's try negative 1. I like it. So I try negative 1. I get y equals all this stuff. So y, again, following order of ops, I'd get 3 plus 6 minus 2. What's that?
7.
That would be 7. And this is where we start to see a little curve to this, because 7 is way up there, right? Can you see how it's no longer a straight line? Very definitely curvy. What if I tried a 2? If I went to the left a couple there, maybe I could go over to the right. If I tried out a 2, this is where it's really going to get weird. I'll say y equals 3 times 2 squared minus 6 times 2 minus 2. Y equals, what, 12 minus 2? What's that?
Negative 2.
Whoa, we've seen that output before, haven't we?
Yeah.
So the point 2, negative 2 is on the graph. And now you can even see more clearly this is not a straight line. Not even close. So how many points really are there on this graph? Yeah, infinite number. There's lots of them, right? So if I were to fill in all the points on the graph, if I had the time and energy, I would find that it has this nice curvy kind of bend to it, and it would actually continue on up and have this lovely symmetry. That's actually one of my better graphs.
So if we just
It actually is fairly smooth. Usually it's got this like growth we need to cut off and everything. And so if you did plot all the points, if you did this really detailed table of values with like 0.1 and 0.2 and 0.3 and all these things, you'd come up with all those extra points in between and you'd form this lovely shape. So I was kind of surprised, like the primary way, like if you feel like really clueless about how to graph something, one of the ways you could start is to create a table of values and plot those points. This is far from the best way of doing this, but it's a way that you could at least get started. Does that make sense? Now the quadratic formula would actually come into play here. Like I said, most of you are doing this. The quadratic formula has the potential to tell us some really important points. And let's see, I bet you can do this. I think you can do this. So here's let me rewrite the equation. This equation right here. I think this could be really, really good. So here it is. Y equals 3x squared minus 6x minus 2. So to use the quadratic formula, a quadratic equation has to be in standard form, which means, I hope you're listening, ax squared plus bx plus c equals 0. So this is not in that form right now, is it?
No.
It's x squared plus bx plus c equals y. So if I did this, now it's in that lovely standard form where using the quadratic formula actually does make sense.
what happens to y?
I replaced it with a 0, didn't I? So here's the thing. If I replace the y with a 0, what part of the graph am I talking about? I like that. I think it's an okay worded question. If y is 0, it's just what I'm saying there, right? I replaced the y with 0. So if y is 0, what part of the graph am I talking about? Close. That's a little too detailed. That could be it, but be a little more general. The x-axis. Isn't that the place where y is always 0? Including the origin. But if I were to do this, if I were to set the y equal to 0 and use the quadratic formula and solve it like some of you did, I would actually get these 2 points right here. Oops. This one here and that one there. That's the place where y is 0. That would tell me where the graph touches or crosses the x-axis in this case. We would call, now I'll talk about the name of those here in a second. But yeah, so if you did the quadratic formula correctly, you actually found those 2 points. Maybe you didn't know it, but you did. Okay. So let's talk real briefly about this in general. Then I've got one example for us to work on, and I'll kind of guide you through some of the key things here. Like I mentioned, creating a table of values, I hope you're really listening here. Creating a table of values, although is useful, it is not the most effective way to get good graphs. I'll show you one of the more effective ways besides just this. Make sense? Okay, so let's talk about the graph that resulted from this. Here we go. It's right here. I said this yesterday. You guys remember the graph of a quadratic is called a blank parabola. There you go. So I think it's really important that we use good vocabulary, because if you say, hey, Mr. Anderson, I was graphing that U-shaped thingy, the dealy bob with the curve, the thing that's not a line, all these like vague descriptions. If you just say, oh, I did a parabola, we all know what you're talking about. Instead of like the stuff with the thing and the vertex with the curvy deal. We might know what you're talking about, but we might not. You might not know what you're talking about either. We'll see. Okay, so this is called a parabola. I want to give you guys the key features of the graph. So key feature number 1 is this turnaround point down here where the parabola turns around. It's called, does anybody know? All right, you're going to learn something new, or maybe you'll just remember this. This is called a vertex. Hey. Everything work out? Yeah. Cool. All right, so called a vertex, it's where the parabola turns around. The parabola could actually open upside down too. So it's wherever the parabola turns around. It's called the vertex. I mentioned this earlier. Did you guys notice that there was a very lovely symmetry on that parabola that I drew? And you can probably see it here too. This purple line that I'm drawing here, I'm going to turn it in, oh, come on. Here we go. I'm going to turn it into a dotted line because it's not really a part of the parabola's graph. This little purple line that I'm drawing in here, this is called the line, or sometimes known as the axis of symmetry. And you can probably see why it's called that, because doesn't it split the parabola right in half? 2 equal halves. That's called the axis, or the line of symmetry. And then the final key points here to discuss would be these 2 green points, there and there. Those are those 2 points I talked about, how you could use the quadratic formula to help you find those. These are called the x-intercepts. In this one, there's 2 of them. Can you guys imagine a scenario where a parabola would have no x-intercepts at all?
It was below or above the x-axis
If it was above
or below.
or below and opening which direction? Yeah, so if it was above and opening up, no x-intercepts, right? Or if it was below and
Down.
opening down, no x-intercepts, right?
Well, there's always going to be a vertex and an axis. So
Always going to be a vertex, always going to be an axis of symmetry, but x-intercepts, maybe, maybe not. Can anybody imagine a scenario where there's only one
when it's facing
x-intercept?
below and facing left or right.
No, so you bring up a cool idea like this right here.
No. No, like above it, and then eventually the one line would intersect the X, but the other one
All
would
right.
keep on going.
I think like this guy right here.
No.
No? That's what he was describing. Doesn't this have one x-intercept? And you're saying something about something keep going.
Like it's above and it's facing right or something. And
So
then
this.
one line.
It's the same thing you're trying to say. I get what she's saying that like,
Draw it.
it would go.
Like
I don't know.
If it
I was
was
just trying to...
like this, and then it would eventually like cross eventually.
Oh, gotcha. Okay, so can anybody... So what she's describing right there, would it pass the vertical line test?
No.
No. So it's not a function, so we're not going to look at it.
Oh.
We're not going to look at it. There are actually, like, so you know, like when you get to another class, like say Algebra 2, pre-calc, something like that, you will look at some graphs that are sort of like what you're describing. For us, we're going to stick with only functions where y is a function of x. So I don't think we would look at that, but put that idea on hold for now. But that would be a case where you have one x-intercept. I agree. Okay. Witt's idea would be more along the lines of what we would look at in this class, where the vertex is just like right there on the x-axis. But like your idea is very valid too. So we just won't look at it in this class. Okay. That's just terminology stuff. Can you guys also see, this is not new, can you guys also see that there's a y-intercept as well? What would be the y-intercept for this particular parabola? Yeah, -2. It's right there. So there's a y-intercept as well, and there are cutesy ways of finding that also. Okay. So these are your key points. And so when we're going to graph one together here in a second. Let's see here. Class started at 05. So we're done. Okay, we got time to do this. And you're going to ask lots of good questions if I do anything that confuses you, right? Okay, so I'm going to give you some good ideas on how to efficiently graph these. So here we go. Flip over to our, are there any questions on this? Okay, let's flip over to our last one. I think it's the last one. Yep, it is. Okay, so this is where I'm going to give you hopefully some really good direct instruction on the most efficient way to do this. But I'll get hopefully some good input from you guys as well. I'm going to give you a list of things to do, and this list is simply an attempt to help you be efficient and not be all over the place and not know when to do what. Okay? So step 1. We're going to find that axis of symmetry. So find the axis of symmetry first. If you can find that, you'll be on your way. So here's how you do it. Here's how you find the axis of symmetry. What I'm about to show you actually has its origins in calculus, believe it or not, where this comes from. But here it is. Here's your axis of symmetry. It's x equals -b over 2a. Now we've done a lot of work with the a and the b and the c doing the quadratic formula. It's the same a, b, and c, right? So -b over 2a. So let's figure this out. For us, what is our b value on this one? It's 8. Yep. So it'd be -8 over, what's my a value? So it'd be 2 times 1. So -8 over 2 is really -4. So my axis of symmetry is -4. And by the way, I'm recording this on video. So if you're doing your homework later and you're like, oh my gosh, how do I find the axis of symmetry? I forgot. This is at minute 19 in the video. Be easy for you to look back up. Your book has it. Hopefully be helpful for you. Okay, so I'm going to put this in. Let's see here. I'll put it in right here. -4 for my axis of symmetry is right there. And like I said before, I usually make this a dotted line because this isn't officially the graph of the parabola. This is just kind of a visual aid to help me get there. Okay, so axis of symmetry, x equals -b over 2a. Comes right out of the quadratic formula too, if you want to think about it like that. Anyways, here we go. Step number 2. This will be the first point on the parabola. We need to find the vertex. So this is where I want you guys to do a little bit of thinking. how does the vertex relate to the axis of symmetry? It's on it, right? It's on the axis of symmetry. So the vertex is a point, x comma y, something comma something. So because the vertex is actually on the axis of symmetry, I actually know part of the vertex. What do you guys think? The vertex would be something comma something?
Well, would you just plug in -4 in the equation?
Yeah, so wouldn't the vertex be -4 comma something? We've got to figure the other part out still. So the vertex x coordinate should always match the axis of symmetry because vertex is on the axis of symmetry. Okay, so then you said plug in, so let's plug in. So it'd be y equals -4 squared plus 8 times -4 plus 15. What do you guys think that is? It's -1. Very good. Follow the order of opposites, and I think I agree with you. Okay. So the first point on the parabola is going to be -4, -1. So how about right there? Okay, so then the only other thing I got to do here is get 2 other points that are actually on the parabola. And I am most often going to suggest to you that those 2 other points be x-intercepts. So I'll just put, x-intercepts. Anybody have any ideas on how I could find those x-intercepts, the place where the parabola hits the x-axis? 0 for what? No, not 0 for the x. 0 for y, right? Remember how I replaced the y with 0? So if I go back in there and I say 0 equals x squared plus 8x plus 15, I'm basically saying, hey, when y is 0, we're talking about the x-axis now. When y is 0, what are the x's? This is where all your skills with the quadratic formula and factoring and all those good things would hopefully serve you very well. So take a minute, see if you can solve that equation. If you can, you'll have the x-intercepts, and you'll essentially have your parabola. Okay? So see if you can solve that equation, something you've done lots of. Give it a shot. Probably closer to 50-50 than anything else. About half of you saw that this could be factored, and you factored it. And the other half of you did the quadratic formula. And if you did everything correctly, regardless of method, you got the same answers. So this does, maybe I'll show you both real quick. This does factor if you do your little box method. You get this. And then you follow your 0 factor property, and you set each factor equal to 0. You get this, and you get x equals -3. You get x equals -5. So those points are on the graph. They're here. Those are my x-intercepts there and there. So I could draw my parabola there. Some of you did the quadratic formula, and that works too. So you would have said x equals -8 plus or minus the square root of 8 squared minus 4 times 15 times 1 all over 2a. When you do all your work here, you get -8 plus or minus the square root of 4 over 2, which would give me -8 plus or minus 2 over 2. Talked with a number of folks that tried to do some canceling in there. I would encourage you to not cancel at this point. There's a little more than meets the eye to this, so I would not do that. -8 plus 2 is -6 over 2 is -3. And then -8 minus 2 is -10 over 2 is -5. Of course, we got the same thing. So a couple things to talk about here. Once you get those 2 points on the graph, you know what you do? You certainly don't do this. It's not a V, right? I know it looks like it could be a V with a kind of a pointy thing there at the bottom, but it is not. It's a smooth curve. So instead of the pointy V, we're going to do our best, and I use that term sincerely. Now that's not too bad. See if the other half. Yeah, see, it's kind of hard. It kind of flattened out there a little bit. You do your best to draw a nice, smooth, curvy parabola-like shape. So avoid stuff like this, please, where like one of them is just a straight line, or they're both straight lines. Neither half is a straight line. They're both lovely parabola-like curves. I would look at that and say that's pretty good. I'm certainly not going to take off some credit on a quiz if you have like a little wiggle to your parabola and it's not like this perfect parabolic shape. That's what a graphing utility would be for on your calculator or a computer or something. But I do not want to see like these hard, sharp points, or perhaps worse than the lines would be something like this, where you just have this radically, totally not the right graph at all, and you're missing the points. And so I don't want to see that. I want to see, here's my last try. Please don't pack up yet. A couple of questions. It's always that right half. Okay, so a couple of questions for you on this. Do you see how I've labeled the vertex? Like it's just a dot right there, and my two other points. Okay, and I got my axis symmetry. These are all the things you need to have labeled. You don't have to, like if it were a quiz or a test, I don't need to see this. And if you want to put this, that's no problem. I don't need to see this. If you want to put this in there to remind yourself, be my guest. I mean, that's great if that helps you, if you actually label them with words. When I say label, I mean they need to be on the graph and obvious, like a point right there, or the dotted line for the axis symmetry. They need to be on the graph versus not. So consider that. And then maybe one other thing here as far as what you could have done with this graph. I suggested you use the x-intercepts to find the other 2 points, right? So what if you had a graph, I'll just make up a different one. What if you had a graph whose axis of symmetry, let's say, was over here, and maybe the vertex is up here. And what if it opened up like we talked about before? What if it opened up? There's no x-intercepts. So if you tried to do this and you tried to do the quadratic formula or the factoring thing, you're going to get like no solution, right? So if there's no x-intercepts, there's no solution to those equations. What would be something you could do to find those other 2 points, but not using the quadratic formula factoring x-intercept routine?
Look into the, what's it called, the table.
Make a table. We're coming full circle back to what we did at the start. Couldn't you look at this and say, why don't I make just a brief table and say, my axis of symmetry, what is my axis of symmetry for this new parabola? 5. So if we went off Noel's idea, what would be, in your opinion, a smart number to plug in for x? 0 always feels like a good one, but I'm actually going to say maybe not the best one.
3.
I get 3 is pretty good, 1 is pretty good. I think there's 2 of them that I would say would be even better. Say again?
4 and 6.
4 and 6. Why on earth would we pick a 4 and a 6? Isn't one of them just to the left of the axis of symmetry? And the other one is just to the right of the axis of symmetry? So this would be a way that you could do this. So again, if you ever find yourself stuck and you're like, whoa, I tried to find the x-intercepts and there weren't any because my equation had no solution, what do I do? Remember, whether you're graphing lines or parabolas or later on exponentials or trigonometric graphs or whatever, you know what you can always turn to? Make a table. Plot a couple of points. See if you can start to get a sense of the graph based on that. Any questions at all on parabolas? Okay, that's great. So then we got about 5 minutes here, and I'm happy to do whatever you want with those 5 minutes. One thing is not going to be to just let you roam the halls. A couple things to consider here. We do have a DMR. Were we supposed to have one today?
Yeah.
Did I mess that up?
Sorry, guys.
Oh, concept quiz. We were supposed to have a concept quiz today. Yeah. Well, I guess it's going to be tomorrow then.
Yeah.
Yeah, please don't do that. Please, were you thinking that the whole time?
No, I really
Okay,
wasn't.
yeah.
I literally just-
I don't know. I'm still messed up. It'll fit tomorrow fine. I'm still messed up from all the snow day stuff. So hold on. Whoa. Slow your roll, please. So, that being said, how comfortable are you guys with the quadratic formula? Because that's what the concept quiz is on. It's only on the quadratic formula. Concept quiz on the quadratic formula.
Like the square.
No. That'll be Friday. So Joe, go ahead. Yeah, it's fine.
So I get to a point where it's like I've simplified everything under the radical.
Yep.
And I have the number that was already outside the plus and minus sign, and then the simplified radical over whatever was on the.
I think you're talking about the thing that I want to talk about too. So let's do this. Let's say you're doing the quadratic formula, and let's say you came up with something like x equals, I don't know, 6 plus or minus the square root of 27 over 3. Right? And so I think, Joe, what you just said is you would do something like this, and you'd recognize that root 27 can be simplified. And so it can be simplified as 3 root 3. Am I starting to come around to what you were talking about?
Yeah.
And now the question is, what do I do from here? And we talked about this yesterday, right? This kind of came up yesterday, and I'm sure there's maybe a WebAssign question in there somewhere that has something like this. What do you do with this? Can I show you what you don't do with this, and then I'll show you what you do with it? So, don't do that. And the reason isn't because it's this arbitrary rule of me trying to make life difficult and all that stuff. We talked about this, right?
Yeah.
It's just mathematically invalid. It's like saying 5 plus 7 is 57 or something along those lines. It just is untrue. So here's what you do. And I would say this would represent the most challenging variety of these. Here's what you do. Look at your numerator and ask yourself, is there a common factor between those two terms?
3.
There's a common factor of 3. So what I'm going to do is I am going to factor out the 3 like this, 3 parentheses, and now I got to write the leftovers. So if I had a 6 and I factored out a 3, what's left over? 2. Plus or minus. If I had a 3 root 3, but I took the factor of 3 out, left over is 1 root 3, or we could just put a root 3. Now that you have factored it, now cancellation is actually a valid thing you could do because, sure, 3 divided by 3 is 1. And so you'd end up with 2 plus or minus root 3. The way I like to think about it is this. As far as why this is true, check this out. Let's go, let's see here. Let's go 3 plus 5 over 3 versus 3 times 5 over 3. Clearly these are different, aren't they? Over here you would say, well, the 3's would cancel out. I get 5. And that's true because 3 times 5 is 15. 15 divided by 3 is 5. We can see that no matter how we do it, it's true. Here, if I do this and I get 1 plus 5, I think the answer is 6. But if I do it the correct way, 3 plus 5 is really 8. Is 8 divided by 3 6? So you see over here we get this conflict. Over here we don't. The fact that this was addition or subtraction makes all the difference. Okay? Anyways, guys, thank you. Have a great rest of your day. See you tomorrow.